force? Let me tell you what you will probably read in your textbooks. Force is a push or pull upon an object, right? Though this cannot be really classified as incorrect, it hardly explains anything about the concept of force. This is what you will assume after reading this definition. You will imagine a stationary object on the ground and someone pushing it or pulling it. Yes, when force is applied, the stationary object will move. But just this does not explain the concept of force entirely. Before we move on to the definition of force, let's clear a few misconceptions about it. Let me ask you a question. This ball is lying at rest on the ground. It's stationary, not moving at all. Is there any force acting on it? Listen to my question carefully. Are there any forces acting on the ball when it is stationary? If your answer was a no, or if you didn't have an answer, it means you don't know the concept of force yet. The answer is yes. There are forces acting on this ball. There is a gravitational force which is trying to pull the ball towards the center of the earth. And the ground is applying an equal force exactly in the opposite direction. This force is called the normal force. Because these two forces are balanced, they do not change the position of an object. The net force acting on the ball is zero. So what does this tell you? Just humans pushing or pulling is not the only kind of force. And just because there are forces acting on an object will not mean the object will move. For the object to move, there has to be some net force. So now let's say a person softly kicks the ball. What happens then? Yes, the position of the ball changes. Why did the position change? It's because there was another magnitude of force acting on it, and this time the forces were not balanced. The ball moved and there was displacement. But hold on, why did the ball stop moving after covering 15 meters? The ball started moving at a pace and then slowly came to a halt. If there's no force from the other side to stop it, how did it stop? Was there a force which stopped it? Yes, it was friction that stopped the ball. While the force you applied was towards the right, the force of friction was towards the left. Let's make it even more interesting. Assume your screen to be your frame of reference in this example. Also assume that this straight horizontal line is a frictionless flow and there's no air resistance. The ball appears from the left of your screen and moving towards the right at a uniform velocity of 2 meters per second. The only two forces acting on the ball are the gravitational and the normal forces which net each other out. In this setting, will the ball ever stop moving? No, it won't. It will continue to move along the same path at the same speed unless there is another external force which acts on it. Here, as the forces are balanced, the ball will continue to move at 2 meters per second. Most people assume that if the object is moving, then there is some net force acting on it, but that's not true. An object will continue to move at uniform velocity even if the net force on it is zero. So there are two things we've learned here. First, if the object is stationary and the net force acting on it is zero, then it will continue to remain at rest. Second, if the object is moving at uniform velocity and the net force acting on it is zero, then it will continue to move at that same uniform velocity. Now, when this ball is moving at 2 meters per second and there is an external force applied from the left, what will happen? Yes, the ball will accelerate. Its velocity will change. Let's say the velocity changes to 3 meters per second after this external force is applied. After that, the ball will continue to move at 3 meters per second unless acted upon by another external force. So nobody's really seen or touched force. It can only be understood by knowing what happens to an object when force is applied to it. If the body is stationary, do not assume that there is no force acting on it. And if the body is in uniform motion, do not assume that there is some net force acting on it. So what is force? A force is a push or a pull upon an object resulting from its interaction with another object. So when you kick the ball also exerts some force onto your leg. But as the force of your kick is stronger, the ball moves to the right. There are many more concepts we need to understand about force, which we will cover in the next video.
Force and laws of motion. This is the second chapter of physics, where the first chapter we did was motion itself. And this is building up upon that. So we will have to time go back to the concepts of motion, refresh them so that we can understand force and laws of motion. What is motion? Motion is change in position. When one thing changes its position from A to B, it's impossible without moving. You cannot change anybody's position without moving. So that is called motion, change in position. And there are laws which are governing that motion, which we will learn in this chapter. For example, look at the first photograph. It is a boy who is pushing the trolley. So there are a lot of questions which come by looking at this photograph. The first question is, who is pushing the trolley? The boy. What is the boy pushing? The boy is pushing the trolley. In which direction is the boy pushing the trolley? Say in right side. And trolley is changing its position in which direction? Right side. So trolley is changing its position. Trolley is experiencing force. The force is applied by the boy and the force is applied on the trolley. Force applied by the boy. Force applied on the trolley. डिस्प्लेसमेंट या डिस्टेंस ट्रैवल्ड को एस कहते थे पहले वाले चैप्टर में. एस डिस्प्लेसमेंट इज इन डायरेक्शन ऑफ फोर्स. जिस डायरेक्शन में फोर्स दिया जा रहा है ट्रॉली उस डायरेक्शन में जाएगी. सो बॉय इज अप्लाइंग फोर्स इन दिस डायरेक्शन, therefore the trolley is moving in that direction. The trolley moves along the direction we push it. मान लो instead of pushing we start to pull, what will happen? The second diagram comes into picture. The drawer is pulled. The trolley is pushed. The drawer is pulled. When you pull a drawer out, what do? You apply force. And because of this force, what happens? The drawer is opened. That is called change in position. Change in position. पहले ट्रॉली की पोजीशन X थी, थोड़ी देर बाद ट्रॉली Y पे आ गई बिकॉज वी वर पुशिंग. थोड़े टाइम पहले ड्रॉअर का पोजीशन क्लोज था बट वी पुल्ड, applied force, therefore the position of the drawer changed and now it is in open position. So when we apply force, conclusion क्या होगा? When force is applied, there is displacement, there is motion, there is distance traveled, and this distance or displacement is in which direction? It is in the direction of applied force. ड्रॉअर को मैं ऐसे फोर्स अप्लाई करता हूं तो वो ओपन होता है, बट व्हेन आई पुश इट लाइक दिस तो वो क्लोज होता है. So pushing and pulling, that's the next thing which we understand from this discussion. To push and to pull are two kinds of forces. Push and pull is force. Force always has a direction. तुम कौन से डायरेक्शन में फोर्स दे रहे हो वो बहुत इंपॉर्टेंट होता है. Hence, force is vector quantity. Remember scalar and vector? Anything which has direction is vector. Force is a vector quantity because कौन से डायरेक्शन में फोर्स दे रहे हो वो बहुत इंपॉर्टेंट है. Look at this girl who is playing hockey. Who is applying the force? That's my first question. Who is applying the force? Answer is the girl. Wait. Who is applying the force? Can't I say the stick is applying the force? Force is applied on what? On the ball. But can't I say force is applied on the stick? All the statements are correct. Girl apply force on stick. Stick apply force on ball. Therefore, what happens? Ball moves. In which direction? Ball moves in direction of the force. जिस direction में force apply किया है उस direction में ball move करेगा. So ball can move in any direction. Depends तुमने force कौन से direction में apply किया है. As of now, the direction of force is this. Therefore, the ball, okay, no. The direction of force is this. Therefore, you see the ball has moved like this. But if the direction of force was like this, the ball would have moved in this direction. So motion depends on force and it moves in that direction in which direction the force is applied, because force is vector. If this is the normal position of the spring, no force is applied. But when you pull the string, the spring, pull in opposite directions, the spring moves. Yes. Does it have displacement? Maybe. Is it moving? No. क्या change हुआ? When force was applied, which force? The pull force. Pull or push दो होता है. When force was applied, what happened in the spring was shape changed. तो जरूरी नहीं है कि जब फोर्स अप्लाई करते हो तो हमेशा चेंज इन पोजीशन, डिस्प्लेसमेंट या मोशन होता है. Sometimes shape can also change. That's why this diagram has been included, that when you pull a spring, the shape of the spring changes. So force can change shape. स्प्रिंग को पुल कर रहे थे, बट यहां हम बॉल को पुश कर रहे हैं. टेक अ बलून और अ बॉल. द शेप ऑफ द बलून or ball is more or less a perfect circle. But what happens when you push it with both your hands? When you push it with both your hands, the ball changes shape. And it changes shape depending on which direction the forces are applied by the hands. देखो क्या लिखा है यहाँ पे. A spring expands on application of force, that's change in shape, and spherical rubber ball becomes oblong as we apply force on it, which is also change in shape. So we have discussed moving trolleys, opening and closing of drawers, hitting the ball with the stick, pulling the spring, pushing the ball, etc. Everywhere force was involved and there was something happening to the object. The summary: what can a force do? The force can change the shape of the object. It can change the speed of the object. It can change direction of the object. It can make stationary things move and it can make moving things stop. Let's discuss examples of each. Force can change the shape of this comb. As long as I am applying force, the shape is changed. But the minute I release force, the shape changes again and becomes normal. This is called change in shape. Force can change the speed. Fan. Imagine there is a fan which is stationary. Stationary मतलब not moving. तो जो पंखा मूव नहीं कर रहा है उसको हाथ से मारो तो घूमने लगेगा. उसकी स्पीड पहले 0 थी, फिर 5 बन गई. That's called change in speed. 0 to 5. और 2-4 बार मारो तो स्पीड बढ़ जाएगी 5 to 10. और बहुत सारे हाथ मारते रहोगे तो फैन विल पिक अप हाई स्पीड 20. बट कैन यू स्टॉप दिस मूविंग फैन? जो तुमने हाथ मार मार के घुमाया है उसको तुम स्टॉप भी कर सकते हो एंड ब्रिंग द स्पीड बैक टू 0. Therefore, force can change the speed. How can force change direction? क्रिकेट. क्रिकेट में जब एक सुपर फास्ट बॉलर, दिस इज द पिच, these are the 3 stumps. जब एक फास्ट बॉलर बॉल फेंकता है तो बॉल स्टार्ट्स इट्स जर्नी फ्रॉम हियर, फिर वो टप्पा खाता है and it goes to the batsman. Now, when it's a fast ball, all batsman has to do is touch the ball. सिर्फ उसको मारना भी नहीं है, सिर्फ उसको टच करो तो बॉल की डायरेक्शन चेंज हो जाएगी. That's all. Who applied the force? Bat applied the force. In which direction? In this direction. And therefore the ball started moving in that direction. It was just change in direction. No extra force needed to be applied. Force can make stationary things move and force can make moving things to stop. तो सेम फैन वाला एग्जांपल है कि पंखा जो नहीं घूम रहा है उसको घुमा सकता है और जो घूम रहा है उसको स्टॉप कर सकता है. There are 2 types of forces: balanced and unbalanced force. It's almost straight. Now, I, with my two hands, I push the comb on both the directions. तो मेरा राइट हैंड उसको ऊपर पुश कर रहा है, मेरा लेफ्ट हैंड नीचे पुश कर रहा है. And when I push, nothing happens. No change in shape, no change in position, nothing. Such forces where nothing happens is called balanced forces. Balanced forces are forces where there is no change in state of motion. अब ये state of motion क्या है? Stationary मतलब not moving, that's a state of motion. Moving is a state of motion. Acceleration या accelerated motion is a state of motion. Retardation मतलब ब्रेक अप्लाई करना is also a state of motion. तो state of motion समझ लो क्या होता है. State of motion means stationary, not moving, v is equal to 0. Uniform motion, v is equal to constant. Accelerated motion, acceleration is positive and velocity is increasing. Retarded motion, acceleration is negative and v is decreasing. Motionless, velocity 0. ये सब states of motion है. Are you moving, not moving, moving with constant velocity, moving with constant acceleration, etc., etc. And all these states of motion, the change happens because of applied force. बिना force के ये change करना impossible है. You cannot change the state of motion without force. Imagine एक ट्रेन का इंजन है जो स्टेशनरी है, क्या वो अपने आप मूव करना शुरू कर देगा? नहीं. It will only move when enough force is applied through burning steam or coal or whatever, petrol, diesel. Stationary to moving, moving to stationary, everywhere force is needed to change the state of motion. Okay, let's discuss this for some time. Force is needed to change the state of motion. Fan is off, motionless. How to apply force and what will happen to the fan? Provide electricity, hence motor moves, hence fan moves. तो बंद फैन को चालू करने के लिए force is applied and that force is applied by the motor through use of electricity. But मान लो कि electricity नहीं है. Provide a push to the fan blade. मारो उसको हाथ से एक बार तो पंखा घूमेगा थोड़ी देर के लिए. That is also possible. That's called change in state of motion by applying force. But fan is moving. Stop it. How to stop a moving fan? पहला option, switch off. No electricity. फिर भी फैन तो घूमते ही रहता है, बट वो स्लो हो रहा है. फैन इज मूविंग but slowing down. Why is the fan slowing down? मैं तो उसको हाथ नहीं लगा रहा हूं, मैंने सिर्फ स्विच बंद की है, तो पंखा स्लो क्यों हो जाता है? फ्रिक्शन. And friction is a type of force, and it's a natural force. फ्रिक्शन डालना नहीं पड़ता है, फ्रिक्शन लगाना नहीं पड़ता है, फ्रिक्शन बस होता है हर जगह पे. स्विच बंद कर दो, अपने आप वो फ्रिक्शन से धीरे धीरे बंद हो जाएगा. Swing. My niece loves to swing to and fro. How to start a swing? Simple answer is push. How to stop a swing? Pull कह सकते हो या apply force with hands. Apply force on the ropes. उसको पकड़ लो, जकड़ लो. Right? But does swing stop? Automatically? Answer is yes. The swing can stop automatically. How? Because there is friction. तो 4 बार धक्का दे दो, फिर बंद कर दो धक्का देना, तो धीरे 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 स्विंग बंद हो जाएगा. Because friction is a force which opposes motion. जिस डायरेक्शन में मोशन हो रहा है उसके सामने की तरफ फ्रिक्शन आता है. फ्रिक्शन तुम्हारा काम बिगाड़ रहा है, फ्रिक्शन तुम्हारे दिए हुए फोर्स को कम कर रहा है, एक्सेट्रा एक्सेट्रा. एनीवेज, balanced and unbalanced forces में I was giving you an example of this, that when I push and pull at the same time, this is called balanced forces. But when I do this, it changes shape because these are unbalanced forces. बैलेंस्ड फोर्सेस में क्या था, आमने सामने फोर्स एक दूसरे को कैंसिल कर देता है, बट यहाँ पे दोनों नीचे खींच रहे हैं, आमने सामने नहीं है. Therefore this is unbalanced force, and unbalanced force leads to a change in shape. Imagine this table. It has a brick or a block of wood on it, and you are applying force in this and this direction. मान लो force is measured in newtons. You apply 10 Newton force in this direction, and 10 Newton force in that direction. They will nullify each other. These are called balanced forces. Will the block move? No. Block maintains original state of motion. इसलिए मैंने state of motion पहले ही समझाया. What is the original state of motion of the block? We can call it motionless. और साइंस में motionless को कहते हैं stationary. So the block was stationary. Then we applied 10 newtons in x direction, 10 newtons in y direction, but these were balanced forces. Therefore, what happened to the block? No motion. The block maintains the original state of motion, मतलब motionless या stationary. But मान लो that instead of 10-10, I apply 50 on y side and 10 on x side. Now these are called unbalanced forces. Balanced, unbalanced forces. We were discussing the table that what would happen if 10 Newton force is applied on both sides. The object will not change its state of motion. Object जैसा था वैसा रहेगा. Object stationary है, stationary रहेगा because 10 Newton force was applied in y direction and same 10 Newton force was applied in x direction. This means the net force is 0. Plus 10 minus 10 overall 0. But मान लो कि 10 की जगह पे मैं 50 अप्लाई करता हूँ. I apply 50 Newton force in this direction and 10 Newton force in this direction. The object now will not remain stationary because these forces are called unbalanced forces. And unbalanced forces cause change in state of motion. और चेंज इन स्टेट ऑफ मोशन मतलब जो भी मोशन का स्टेट है वो बदल जाएगा. पहले वो स्टेशनरी था, अब इट विल स्टार्ट टू मूव इन दिस डायरेक्शन एंड द नेट फोर्स इज नॉट 0, द नेट फोर्स इज 40 नाउ बिकॉज 50 जिसमें से 10 कम हो जाएगा 40. दैट्स कॉल्ड द कॉन्सेप्ट ऑफ नेट फोर्स, बैलेंस्ड फोर्स एंड अनबैलेंस्ड फोर्स. बट मान लो कि कोई कुछ पुल और पुश कर ही नहीं रहा है. टेबल पे एक ब्रिक ऐसे ही पड़ा है बस. A brick is lying on the top of the table just like that. What would you say? First question, is force acting on this brick? Answer is yes or no. Answer is yes. Nobody is pushing the brick, nobody is pulling the brick, but still force is acting on the brick. Which force? Two types of forces. Downward force is gravitational force, and second force is an upward force called normal force, which is applied by the table on the book. टेबल सामने फोर्स अप्लाई करता है. और ये दोनों फोर्स सेम है कि नहीं है? ये दोनों फोर्स सेम है. दे आर बैलेंस्ड फोर्सेस. और बैलेंस्ड फोर्सेस में जो जैसा है वैसा ही रहता है. द ब्रिक इज नॉट मूविंग, therefore in future also it will not move because the forces applied are balanced. If I start pushing and pulling, still a new set of balanced forces can be applied, 10 Newton, 10 Newton. The brick will not move. मैं और दो जन को बुलाता हूं, एक को बोलता हूं तुम यहां से खींचो, दूसरे को बोलता हूं तुम यहां से खींचो, बट सेम खींचना, 20 Newton force अप्लाई करना, still the object will not move. So object is not moving does not mean there is no force. The object is not moving can mean that force is there, but the force is balanced force. Look at this discussion now. Two students are pushing the box. This is the push of the students. 20 Newton force. The box does not move because exact same 20 Newton force is applied by the box in the opposite direction. Therefore, it becomes balanced forces. Or balanced forces में there is no change in state of motion. जो जैसा था वैसा रहेगा. The box was not moving. It will not move because the children applied 20 Newtons and the box applied 20 Newtons in the opposite direction. But how can box apply force? Box is a dead thing. But every dead thing or living thing has something called as force of friction. And this friction force is this opposite force applied by the box. अब the children are determined, they want to move the box, they increase their force to 50 newtons. सामने बॉक्स भी अपना फोर्स बढ़ा देता है 50 न्यूटन्स. This is called balanced force. Will the box move? No. There will be no change in the motion of the box. Box will not move. तुमने प्रेशर बढ़ाया तो बॉक्स ने सामने बढ़ा दिया. Automatic, naturally. Although it's a dead thing. कहाँ से आया ये फोर्स? Force of friction. But the children will not give up. The children apply 100 Newton force in this direction. और बॉक्स की कैपेसिटी थी 70 न्यूटन्स की जो सामने अप्लाई कर रहा है. नाउ दिस इज कॉल्ड अनबैलेंस्ड फोर्स. एंड अनबैलेंस्ड फोर्स में देयर इज समथिंग कॉल्ड एज नेट फोर्स. और नेट फोर्स में 100 हम लगा रहे हैं, 70 सामने हो रहा है, 30 न्यूटन इज द नेट फोर्स which is being applied in this direction. Therefore the box starts to move. मतलब there is change in state of motion. जो पहले stationary था अब वो हिल रहा है, and that change in state of motion comes only because of unbalanced forces. So hope you have understood what is balanced force and what is unbalanced force. पंजा लड़ाते, जब पंजा लड़ाते हैं दो जन, तो इमेजिन दोनों के हाथ सेम पोजीशन पे. This means this is balanced force. Person A and person B are applying same amount of force in opposite direction, therefore it's a balanced force. Therefore the hand are not moving anywhere. But मान लो I'm lefty, my left hand has more power. पंजा लड़ा रहे हैं और left ज्यादा force दे रहा है, तो what will happen is this will happen. There will be motion, and there is motion because it is an unbalanced force. Because left has more force and right is able to give back less force. So forces are balanced and unbalanced. And only unbalanced forces can lead to motion. Also, when things are stationary, it does not mean कि उसके ऊपर कोई force नहीं है. उसके ऊपर force है, but वो balanced force है, इसलिए वो stationary पड़ा हुआ. Before doing the first law of motion, see this video. Try to understand, because it's a very good video explaining balanced, unbalanced forces and how things move in presence and absence of force.
We hear the usage of this term many times in our day-to-day life. We might not know that we're using it. Opening a door, riding a bicycle, lifting an object are few of the most common things that we perform in our daily lives, and all these require a force. What is a force? Consider a ball lying on the ground at rest. It's not moving. Suppose this player here wants to pass this ball to his teammate who's standing on the other side of the pitch. How will he do that? He needs to make this ball move in the direction of his teammate. So he will kick the ball in the direction of his teammate. When he kicks the ball, we say that he applied a force on the football. Yes, the kick is nothing but the force he applied on the ball. Now suppose that we have a desk here at point A. A person wants to move this desk from point A to this point B. Again, how will he do that? Here, he will push the desk towards point B. In this case, we say that the person applied a force on the desk in order to shift it. The push here is the force that the person applied on the desk. Similarly, when you lift some object from the table, we say that you applied a force on that object. Here, the force is applied in the form of lifting. So, forces are nothing but actions such as kicking, pushing, lifting, etc. performed on objects. There are many such actions that we can perform. We have already seen few of these. Some more of them are given below. While riding a bicycle, we pedal it continuously to keep it in motion. Here, pedaling is the force that we apply on a bicycle. Hitting the hammer on a nail is also a force applied on the nail. What about stopping a moving ball? Yes, even stopping the ball means we are applying a force on it. We applied some force to stop the ball. Opening a drawer, plucking the string of a guitar, moving a piece on a chessboard are some of the other actions performed on objects. So performing these actions on objects is nothing but applying force on them. But these are just a handful of simply too many actions that we can perform on the objects. And it's not possible to write each one of those. But we can categorize all these actions into two basic ones. That is, we can describe all these actions under two actions, namely pushing and pulling. For example, when we open this drawer, we are simply pulling the knob of the drawer to open it. Similarly, when we are drawing or lifting a bucket of water from the well, we are pulling the bucket towards us. What are the actions that can be described under pushing? Actions such as passing the ball, hitting the hammer on the nail, etc. can be thought of as pushing an object. Are there any actions that can be described under both? Yes, there are. Suppose there's a book on the table, you can either pull it towards you like this or push it away from you like this. So moving an object can be described under both. Similarly, opening or shutting a door can be thought of as both. So we can safely say at this point that the forces are nothing but the push or pull applied on objects. Forces are due to interaction between the bodies or objects. What does it mean? Let's go back to our first example of this video. Here, in order to pass the ball to his teammate, the player must move it. That is, he must interact with the ball to move it in the direction of his teammate. He interacts with the ball by kicking it. The ball and the player interact with each other. In the second example, in order to move the desk from point A to point B, he must interact with the desk. We will study more on these interactions in the future videos. Now, since we are clear with the basic understanding of what force is, let me put its definition in front of you. It states that a force is a push or pull upon an object resulting from the object's interaction with another object. In the next lesson, we will talk more about these interactions. See you there.
So, we have learnt a lot of words we have learnt. And especially from the video which you saw, you must have understood कि कोई चीज अगर non-stop घूम रही है, that does not mean कि उसके ऊपर force है. हाँ, अगर कोई ball बस जा रहा है, भाग रहा है, there is no friction on the ground, the ball will continue forever, and that is in absence of force. There is no force acting on it. सिर्फ gravity और normal दो है opposite forces which are balanced forces. तो what can happen without force? How to answer this question? What will happen in absence of force or in absence of unbalanced force? Unbalanced force ना हो या force ही ना हो तो क्या होगा? People would guess this as answer. The object would remain stationary. जो चीज नहीं हिल रही है वो नहीं हिलेगी. Look at this. This is a box. Is it moving? It's not moving. Why? Because there is no force acting on it. Wrong. Force is acting on it. Box के ऊपर force act कर रहा है. There are two types of forces. डाउनवर्ड डायरेक्शन में ग्रेविटेशनल फोर्स, अपवर्ड डायरेक्शन में नॉर्मल फोर्स जो बेड इसको दे रहा है, बट ये हिल नहीं रहा है, but unbalanced or imbalanced forces are still there. So what happens in absence of force or in absence of unbalanced force? The object would remain stationary. But there is another answer. An object would remain moving if it is moving previously. जो हमने वो एनिमेटेड वीडियो में देखा कि 2 मीटर पर सेकंड पे बॉल जा रहा था, और तो वो 2 मीटर पर सेकंड पे चलते ही रहेगा जब तक कोई एक्स्ट्रा अनबैलेंस्ड फोर्स उस पर एक्ट ना करे. दिस इज फर्स्ट सेंटेंस. Another question I will try to ask you: what will happen in presence of force or in presence of unbalanced forces or unbalanced force? अब दो चीज हो सकती है या बहुत सारी चीज हो सकती है. अनबैलेंस्ड फोर्सेस में stationary starts to move. Moving picks up speed. High speed becomes low speed. Or moving object stops. ये सब हो सकता है. अनबैलेंस्ड फोर्सेस की वजह से दुनिया चलती है. स्टेशनरी चीज हिलने लगती है, स्लो चीज फास्ट हो जाती है, फास्ट चीज स्लो हो जाती है, और हिलती हुई चीज स्टॉप हो जाती है. ऑल इज पॉसिबल थैंक्स टू अनबैलेंस्ड फोर्सेस. Let's look at the first law of motion now. गैलीलियो ने एक एक्सपेरिमेंट की थी, और वो एक्सपेरिमेंट क्या है वो ये फिगर में से समझ में आता है. See, reading physics is very, very boring and very difficult to explain. You have to read the textbook, but I will give you the understanding part of it. गैलीलियो ने एक एक्सपेरिमेंट किया था, दो एक्सपेरिमेंट किए थे, वो मैं दोनों समझाने जा रहा हूं. इट्स ओनली बाय अंडरस्टैंडिंग इट यू कैन अंडरस्टैंड फिजिक्स. टेक्स्ट बुक पढ़ोगे तो कुछ नहीं समझ में आएगा, तो ध्यान से समझ के सोच के. What did Galileo do? Galileo took two planes, दो स्लोप बनाए. पहले स्लोप के टॉप से बॉल को छोड़ दिया, फेंका नहीं, फोर्स अप्लाई नहीं किया है, सिर्फ रिलीज कर दिया. When the ball was released, automatically it went down because of gravitational force. ग्रेविटी ने बॉल को नीचे खींचा, और बॉल नीचे आने के बाद यहां से ऊपर चढ़ने लगा. सो गैलीलियो ने क्या कंक्लूड किया इससे? गैलीलियो सेड दैट द बॉल is moving down because of gravitational force or gravity. But why is the ball moving up? The ball is moving up because it is in motion and wants to remain in motion. गैलीलियो ने दिमाग लगाया कि बॉल मूव हो रहा है, और अगर बॉल मूव हो रहा है तो उसको मूव होते रहना है. और अगर बॉल ने डिसाइड किया है दैट आई एम मूविंग, आई एम मूविंग, आई एम मूविंग, आई एम मूविंग, एक बार ग्राउंड लेवल आ गया, उसके बाद और नीचे नहीं जा सकता है. बट बिकॉज इट इज मूविंग एंड इट वॉन्ट्स टू कंटिन्यू दैट मोशन, इट स्टार्ट्स टू क्लाइम एंड इट रीचेज अ सर्टेन पॉइंट. इससे एक सेंटेंस बनता है दैट ऑब्जेक्ट विच इज इन मोशन wants to remain in motion. इसका एक लाइव एग्जांपल देता हूं. पंखा चालू है क्योंकि स्विच चालू है. स्विच बंद करने के बाद पंखा बंद हो जाता है? नहीं, पंखा थोड़ी देर के लिए घूमते रहता है. दिस मीन्स दैट फैन इज इन मोशन and wants to continue to remain in motion, इलेक्ट्रिसिटी हो के ना हो. तो फिर स्टॉप कैसे होता है? धीरे धीरे. फ्रिक्शन. बट फ्रिक्शन हटा दो तो स्विच बंद करने के बाद भी पंखा चालू ही रहेगा फॉर एवर. बट फ्रिक्शन है मशीन के अंदर, therefore it stops. Second example, listen and imagine carefully. Running race में the participants are running fast. रनिंग रेस जीत गया एक आदमी. उस स्ट्रिंग उसको यहाँ पे टच कर दी, उसको पता है he has won, but still he keeps on running. He doesn't stop. तो रनिंग रेस में फिनिश पॉइंट के बाद भी थोड़े टाइम के लिए वो आदमी दौड़ते ही रहता है. क्यों? द रीजन इज हिज बॉडी इज इन मोशन एंड उसकी बॉडी ने डिसाइड किया है. वो रेस जीत गया है, उसके ब्रेन ने बोला हाश दौड़ना बंद कर दो, लेकिन दौड़ना बंद होता नहीं है. ही कंटिन्यूज टू रन फॉर सम टाइम ऑटोमेटिकली. तो फिर दौड़ते ही रहना चाहिए ना? नहीं. बाद में the legs start applying pressure in opposite direction. There is friction from the ground and slowly he stops. But immediately stop नहीं होता है because his body was in motion. Instantly after winning the race also his body wants to remain in motion. ये दूसरा एग्जाम्पल दिया मैं. तीसरा एग्जाम्पल, मैं बस में खड़ा हूं. The bus is moving at a speed of 60 kilometer per hour. Imagine karna. It's all about imagination. So you and me are standing in a bus. Bus is going steadily at 60 kilometers per hour, which means the speed of our body is also 60 kilometer per hour. अब अचानक रेड सिग्नल आ जाती. Bus is moving in this direction at 60 km per hour. Therefore, my body inside is also moving with the bus at 60 km per hour and I am holding the railing. अब बस को लाल सिग्नल दिखती है. ड्राइवर अप्लाइज ब्रेक्स. When driver applies brakes, the bus stops. But my body does not have brakes. My body was at the speed of 60 and it wants to continue going at the speed of 60. Therefore, जब बस ब्रेक मारती है तो मैं आगे आ जाता हूं. Why do I come forward? Because my body was going at 60, it wants to continue to go at 60. But मेरा हाथ है ना, वो मुझे बचा लेता है. अगर मैं ऊपर पकड़ूंगा नहीं और बस ने ब्रेक मारी तो तुमको पता है इंस्टेंटली गिर जाओ. थर्ड एग्जांपल दिया मैंने. फोर्थ एग्जांपल, the bus is not moving at all. Bus is not moving, it is stationary. बस के अंदर मैं भी खड़ा हूं, आई एम ऑल्सो स्टेशनरी. अचानक बस की इंजन पिक्स अप स्पीड एंड बस स्टार्ट्स टू मूव एट 5 miles per hour और 5 meters per second. अब बस ने स्पीड पकड़ी अचानक, बट मेरी बॉडी जो नहीं हिल रही थी उसको नहीं हिलना है. दिस इज द सेकेंड पार्ट नाउ. टिल नाउ आई वॉज टेलिंग यू that things which are in motion wants to remain in motion. रनिंग रेस में आदमी दौड़ रहा है, उसको थोड़ी देर तक दौड़ना पड़ेगा. पंखा घूम रहा है, स्विच बंद करने के बाद भी उसको थोड़ी देर घूमना पड़ेगा. बॉल यहां तक आ गया, जमीन आ गई है, फिर भी उसको हिलना पड़ेगा और इसलिए वो ऊपर चढ़ जाता है. थिंग्स व्हेन इन मोशन वांट्स टू रिमेन इन मोशन, ये उसका उल्टा एग्जांपल है. आई वाज नॉट मूविंग and therefore even if bus moves, my body still wants to maintain that position that I don't want to move. इसलिए मैं पकड़ू या ना पकड़ू, बस आगे जाएगी तो मैं पीछे जाऊंगा. Because the bus has moved आगे, बट मेरी पोजीशन ये थी, अभी भी मेरी बॉडी को वही पोजीशन चाहिए, इसलिए मैं ऐसे पीछे हो जाता, बिकॉज माई लेग्स आर अटैच्ड विद द बस. बहुत ही कॉम्प्लेक्स है ये. बस मूव्स आगे, बस के साथ लेग्स आर अटैच्ड और बीच में फ्रिक्शन. लेग्स मूव आगे, legs move आगे, but the body does not want to move. This is because of the first law of motion. ये जो first law है उसका basic definition है, जो हिल रहा है उसको हिलते रहना है, जो नहीं हिल रहा है उसको नहीं हिलना है. बट कब तक ऐसा होगा? जब तक कोई अनबैलेंस्ड फोर्स उस पर एक्ट ना करे. ये ना हिलने वाला एक एग्जांपल दे रहा हूं. देयर इज अ स्टैक ऑफ कैरम डाइस. कैरम रम है, कैरम नहीं कुकरी, और कैरम की डाइस को बीच में एक स्टैक करके रखा हुआ है, और स्ट्राइकर से तुमने जोर से एक डाइस को मारा. विल दिस स्टैक फॉल डाउन? नो. स्ट्राइकर विल टेक आउट वन डाइस, बट द स्टैक विल रिमेन वेयर इट इज. उसे नीचे आ जाएगा. क्यों? क्योंकि स्टैक वॉज स्टेशनरी, और स्टैक स्टेशनरी था, इसलिए उसने डिसाइड किया था कि उसको स्टेशनरी ही रहना है. वो तो लास्ट डाइस ने भी डिसाइड किया था, लेकिन लास्ट डाइस को फटका पड़ता है, और फटका मतलब अनबैलेंस्ड फोर्स, इसलिए लास्ट डाइस हार जाता है. लेकिन बाकी के डाइस को किसी ने टच भी नहीं किया है. दे आर नॉट इन मोशन एंड दे वांट टू रिमेन लाइक दैट, देयरफॉर दे स्टे वेयर दे आर, सिर्फ नीचे आ जाते. दैट्स कॉल्ड फर्स्ट लॉ ऑफ मोशन, कि मैं मोशन में नहीं हूं और मुझे मोशन में नहीं आना. एक कार्ड है विच इज केप्ट ऑन अ ग्लास, और ग्लास के ऊपर कॉइन है. तुम जोर से हाथ से कार्ड को मारो, द कार्ड विल फ्लाई अवे and the coin will fall in the glass. Why? Because coin was stationary, and coin had decided that I want to remain stationary. When you push the card, कार्ड पे अनबैलेंस्ड फोर्स एक्ट हुआ है, और कार्ड का जो डिसीजन था कि मैं नहीं हिल रहा हूं, मैं नहीं हिलूंगा, दैट गोज फॉर अ टॉस. टेल लेने जाए, हिलना पड़ेगा, अनबैलेंस्ड फटका पड़ा है. बट कॉइन को किसी ने टच नहीं किया. कॉइन कहता है मैं नहीं हिल रहा हूं और मैं यही रहूंगा, मैं नहीं हिलूंगा, और ऐसा ही होता है. एंड देयरफॉर द कॉइन स्टेज वेयर इट इज. बट इफ द कॉइन स्टेज वेयर इट इज, देयर इज नो बेस, द कार्ड हैज गॉन, देयरफॉर द कॉइन फॉल्स डाउन. All this are explanation of the first law of motion, which reads something like this: an object at rest stays at rest. मैं नहीं हिल रहा हूं, मैं नहीं हिलूंगा फ्यूचर में भी. And object in motion stays in motion. मैं हिल रहा हूं, मैं हिलते ही रहूंगा. सेम स्पीड सेम डायरेक्शन. लेकिन कब तक? This will happen in same speed same direction तब तक जब तक an unbalanced force acts on it. Unbalanced force act करेगा तो ये जो डिसीजन पावर है कि मैं हिल रहा हूं, मैं हिलते रहूंगा, मैं नहीं हिल रहा हूं, मैं नहीं हिलूंगा, उसकी बैंड बच जाती है. दिस इज कॉल्ड फर्स्ट लॉ ऑफ मोशन. अब पंखा स्टॉप हो जाता है क्योंकि वो फ्रिक्शन है उसके अंदर. बट अगर हम फ्रिक्शन निकाल दे तो क्या होगा? वो गैलीलियो के दूसरे एक्सपेरिमेंट से पता चलता. What did Galileo do this time? Galileo took first slope and released the ball and observed कि वो A, B, C slope पे कहां तक जाता है बॉल. तो मैंने रिलीज द बॉल फ्रॉम अ फिक्स हाइट h से रिलीज किया. द बॉल क्लाइम्स द स्लोप एंड रीचेस हियर at point A. फिर उसने स्लोप चेंज किया, थोड़ा सा सुला दिया, वापस बॉल रिलीज किया, द बॉल रीचेस पॉइंट बी हियर, और सुला दिया स्लोप, फिर से वहीं से रिलीज किया, he observes the ball reaches till this point. In short, it does not matter कि तुम्हारा स्लोप स्टीप है कि नहीं है, बड़ा है कि छोटा है, ज्यादा है कि कम है, the ball always attains the same height. ये लॉ है नेचर का कि h हाइट से रिलीज किया हुआ बॉल कब तक ऊपर जाएगा, जब तक वो h हाइट गेन नहीं करता. तो इमेजिन ये स्लोप के ऊपर बॉल कहां तक जाएगा, स्लोप तो इनफाइनाइट है, it will reach till here because it wants the same height. But don't you think something is happening here? What is happening here is, जैसे जैसे स्लोप बदल रहा है, the ball is traveling more distance. Ball travels x distance here, y distance here, z distance here. You can see large amount of distance is traveled here. तो जैसे जैसे स्लोप नीचे आ रहा है, डिस्टेंस ट्रैवल्ड बढ़ते जा रहा है. व्हाट विल हैपन व्हेन देयर इज जीरो स्लोप? जीरो स्लोप मतलब फ्लैट लैंड. फ्लैट फ्रिक्शनलेस सरफेस पे अगर बॉल फेंका तो क्या होगा? दैट्स व्हाट मेक्स गैलीलियो स्पेशल. अदर्स कुड नॉट इमेजिन इट. You think what will happen if you can, without any external help, without any prior knowledge, if you can guess what will happen, then you are equally brilliant like our dear Galileo. Slope 1. Slopes are infinite. Slopes are big, huge. उसका कोई लिमिट नहीं है. The ball is released from this height, so it will always try to reach the same height. उसके ऊपर जाएगा नहीं बॉल. Therefore, ball travels less distance, then more distance, more distance, more distance. अब सोच के बताओ कि अगर बॉल को मैंने सीधा फेंक दिया या सीधा जाने दिया, what will happen to the ball? The ball will never stop. क्यों? The ball will never stop because बॉल को स्टॉप करने का एक ही रीजन था, the ball achieved height h. h हाइट से फेंका हुआ बॉल h हाइट तक पहुंचे तब तक वो चलते रहता है. अब स्लोप ही नहीं है. अगर स्लोप नहीं है तो हाइट h तक पहुंच नहीं पाएगा, और जब तक हाइट h तक नहीं पहुंच पाएगा, it will continue to move. That's why in that video the football was moving at 2 meters per second continuously, because it's the first law of motion कि अगर कोई चीज मूव कर रही है तो वो मूव करती ही रहेगी जब तक उसको कोई स्टॉप नहीं करता. Is this possible in real life on this planet? You throw, release, slope, go on forever? No, because सबसे बड़ा दुश्मन है फ्रिक्शन, और फ्रिक्शन को माइनस करना, 100% जीरो कर देना पॉसिबल नहीं है. फ्रिक्शन हमेशा रहता है. Therefore, this experiment is theoretical. It cannot be done on the planet. That is discussion of first law of motion by Newton, which gives you law of inertia. Law of inertia comes from first law of motion. First law of motion हिंदी में याद रखो, फिर इंग्लिश में लिखना बहुत इजी रहेगा. मैं नहीं हिल रहा हूं, मैं नहीं हिलूंगा. मैं हिल रहा हूं, मैं हिलते रहूंगा. जब तक कोई एक्स्ट्रा फोर्स मुझ पे ना अप्लाई करे. An object which is stationary will remain stationary, which is moving will remain moving until an unbalanced force acts on it. This is the first law of motion, and law of inertia comes from that first law of motion. So law of inertia क्या है? An object at rest stays at rest. मैं नहीं हिल रहा हूं, मैं नहीं हिलूंगा. Object in motion stays in motion with the same speed and same direction unless acted upon an unbalanced force. This is called inertia. और inertia का direct relation है mass के साथ, वजन. कैसे? inertia मतलब mass समझ लो, वजन. ये जो डाइस है, जब स्ट्राइकर से मारा तो एक डाइस हिल गया बट बाकी नहीं हिले, because they all had some mass. मास कम था कि ज्यादा? कम. कैरम की डाइस का मास कितना होता है? ज्यादा नहीं, कम मास था, इसलिए कम इनर्शिया था. और कम इनर्शिया मतलब छोटा डिसीजन पावर, और छोटा डिसीजन पावर चेंज हो सकता. मैंने डिसाइड किया ये पेन में नहीं छोड़ूंगा, दैट्स माय डिसीजन पावर. बट मेरे पास कम मास, कम इनर्शिया, कम एनर्जी है, तो सामने वाला आदमी बोलेगा तूने क्या डिसाइड किया, ये ले छीन लियो. मैंने डिसाइड किया था, बट वो डिसीजन पावर कम था क्योंकि मास कम था, इनर्शिया कम था. इमेजिन दिस पेन इज बीइंग हेल्ड बाय ड्वेन जॉनसन, हॉलीवुड का सलमान भाई. नहीं पता तो गूगल करो द रॉक. तो ड्वेन जॉनसन, हु इज सच अ स्ट्रॉन्ग पर्सन, हैज डिसाइडेड कि ये पेन में नहीं छोड़ूंगा. और उसके डिसीजन पावर में दम है, because he had more mass, therefore he has more inertia, therefore nobody can take it from him. That's called law of inertia. Every object on the planet has inertia. ये कॉइन क्यों अपनी जगह से नहीं हिला और ग्लास के अंदर गिर गया? क्योंकि कॉइन के पास था इनर्शिया, और कॉइन का इनर्शिया इनफ था कि वो वहीं रहे, और बेस निकल गया तो ग्लास में गिर. An object remains in state of rest or in uniform motion in a straight line unless compelled to change that state by an applied force. This is the first law of motion. Object remains in a state of rest if it is in rest, or remains uniform motion if it is uniform motion. कब तक? तब तक जब तक it is compelled to change that state by an applied unbalanced force. In other words, all objects resist change. इसी चीज को उल्टा करके बताओ, मुझे गर्म चीज बिल्कुल पसंद नहीं, इसका मतलब है मुझे ठंडी चीज पसंद. वैसे ऑब्जेक्ट एट रेस्ट रिमेन्स एट रेस्ट, ऑब्जेक्ट इन मोशन रिमेन्स एट मोशन, मतलब दे रेजिस्ट चेंज. उनको चेंज पसंद नहीं, दे रेजिस्ट चेंज. एंड दिस रेजिस्टेंस पावर कि मैं नहीं बदलूंगा, दैट्स कॉल्ड inertia. And therefore the first law of motion is called law of inertia, कि मैं नहीं हिल रहा हूं और मैं नहीं हिलूंगा, या मैं हिल रहा हूं और मैं हिलते रहूंगा. Why do we need seat belts? Imagine this is the car, this is the seat, and you are sitting on that seat. The car is going at 100 km per hour, and when the car is moving at 100, you are also moving at 100. अब car applies brakes suddenly. शॉर्ट ब्रेक्स. जब कार ब्रेक अप्लाई करती है तो कार की स्पीड 100 से 20 हो सकती है, बिकॉज कार्स के टायर में फ्रिक्शन है, वो रोड को पकड़ के स्लो हो जाती. बट तुम्हारी बॉडी के पास ब्रेक्स नहीं है. योर बॉडी continues to move at 100 kilometers per hour. Imagine you will fly out from the car and hit the dashboard because of law of inertia. Law of inertia says my body is in 100 kilometer per hour. It wants to remain at 100 kilometer per hour. तेल लेने जाए गाड़ी, तेल लेने जाए ब्रेक्स. गाड़ी रुके तो रुके, मैं जा रहा हूं 100 पे. और मैं अगर 100 पे चला गया, गाड़ी रुक गई, तो I will dash with the windscreen. एक्सीडेंट इसको बोलते हैं. That's why you require seat belts. सीट बेल्ट का काम है कि गाड़ी जब ब्रेक मारेगी तो तुम आगे नहीं आओगे, तुमको पकड़ के रखेगा कि आगे मत जाओ. और आगे जाना इज नेचुरल. इट्स द फर्स्ट लॉ ऑफ मोशन. वैसे गाड़ी जब टर्न लेती है, when car takes a left turn, your body automatically moves towards right. बिकॉज ये मंदिर है और कार जा रही थी मंदिर के डायरेक्शन में. दिस इज टॉप व्यू ऑफ द कार, सो पार्डन माय ड्राइंग. कार जा रही थी मंदिर के डायरेक्शन में, तो तुम्हारी बॉडी भी मंदिर के डायरेक्शन में जा रही थी. बट सडनली कार टुक अ टर्न. तो कार ने तो टर्न ले लिया, बट यू could not adjust to that new direction. Therefore, तुम जो यहाँ बैठे हो, लेकिन तुम्हारा बॉडी मंदिर के डायरेक्शन में जाना चाहता है. Therefore, you move towards your left. The car has taken a right turn, but your body wants to go to the same direction. Therefore, body moves towards left. This is called first law of motion. And this first law of motion, which is also called law of inertia, is directly related with mass. It's easy to move an empty box, but it is not easy to move a box full of books. Reason: empty box, less mass. Less mass, लेस इनर्शिया. और लेस इनर्शिया का मतलब है मैंने पेन पकड़ी है, मैं नहीं छोड़ूंगा, चल बे. डिसीजन पावर वीक है क्योंकि बॉक्स खाली है, बॉक्स में मास नहीं है, बॉक्स में इनर्शिया नहीं है या इनर्शिया कम है. देयरफॉर यू कैन इजीली पुश द बॉक्स एंड द बॉक्स विल मूव. बट यही बॉक्स अगर बुक्स के साथ भर दो तो box becomes heavy. Heavy means more mass. More mass means more inertia. तुम कितना भी धक्का दो, the box will not move. It's very difficult to move the box because it's heavy. Kick a football versus kick a stone of same size. पत्थर और फुटबॉल जो सेम साइज के है उसको लात मारो. फुटबॉल का मास कम है, इट विल फ्लाई. बट स्टोन का मास ज्यादा है, तुम्हारा पैर टूट जाएगा. दैट्स कॉल्ड लॉ ऑफ इनर्शिया. फुटबॉल बैठा था ऐसे, मैंने डिसाइड किया मैं कहीं नहीं जा रहा हूं, मैं यहाँ पे स्टेशनरी हूं, मैं स्टेशनरी रहूंगा, चल फुट, लात मारी, उड़ गया. बिकॉज इनर्शिया कम था. बट स्टोन ने डिसाइड किया था मैं यहीं हूं, मैं कहीं नहीं जाऊंगा, और वो सच में कहीं नहीं जाता. पैर टूट जाएगा, स्टोन के बॉल को कुछ नहीं होगा. So inertia is directly related to mass. Second law of motion will continue in next lecture. Thank you.